Good morning, students.
Good morning, teacher.
How are you?
We are fine.
Very fine?
Yes.
Your night was good?
Yes.
Okay. Let me welcome one of you, Remy Pick Namasen, to just give us a warm-up and we continue with our lesson.
Thank you.
Good morning.
Good morning.
It's a time of warm-up. Yeah, I'm going to count. Yes?
Yes.
I'm going to count 1, 2, 3. Eyes on me. And then you reply by saying 1, 2, eyes on you. Yes?
Yes.
Okay, let's get started. 1, 2, 3. Eyes on me.
1, 2, 3.
No.
Eyes on you.
1, 2, eyes on
You.
yes. 1, 2, 3. Eyes on me.
1, 2. Eyes on you.
1, 2, 3. Eyes on me.
1, 2. Eyes on you.
One more time. 1, 2, 3. Eyes on me.
1, 2. Eyes on you.
Thank you.
Thank you. Snaps for Namasen. Okay. Which topic are we on? Which unit are we on in mathematics? Marie-Claire. Thank you. Yeah, which unit?
Probability.
Probability. Okay. It is which number? 11. Okay, thank you. Do you know this? What is this? Jean Amour.
That is a bar.
That is a bar. Another one? Eda?
That is straight back.
Oh, straight bar. Okay. Another one? A ball. That is a sa? A sa. Okay. Is it? Okay, a sa. Okay, I want like, what is this? Amadi Chantal?
A ball.
A ball. Okay. Made of? It is a ball made of
Paper.
papers and? Okay, strings. Okay, I want that you take, okay, you forgot that this is a bag. Just take it as a panel. Who ever played basketball?
Me.
Okay. The other panel that they just put the basketball into. They take this as a panel or just as a basketball panel.
Yes.
Okay. And if someone is going to try to throw this ball into the panel 10 times. 10 times.
Yes.
You just imagine this is a panel and this is a ball. You are going to throw this ball into this basket or just panel 10 times. Okay?
Yes.
Are we together?
Yes.
Are we in that situation?
Yes.
Okay. What do you think in those 10 times? What do you think are the possible outcomes that he or she will win or succeed in the panel? How many times? How many times? Okay.
Maybe half.
A half. So 5 times out of 10 times. Okay. Who else? Joel?
7 times.
7 times.
100%.
100%. So it's 10 times out of 10 times. Okay. So we are just thinking, this is what we call theoretical. We are just thinking of what will happen. So now what we are going to do, we are going to see what if it is now in practice, what could be the outcome. So the lesson of today, what do you think is the lesson of today, the key question we can formulate? So we knew that there might be different probabilities of just putting this ball into the basketball, but now we are going in practice. What could be the key question for this for today's lesson.
What can we call the probability that is done after having experiment?
Experiment, okay, thank you. Another one? Is that?
Outcomes and sample space.
Outcomes and sample space.
Experiment.
Okay, thank you. But you have to improve. Is that the question?
Yeah.
Okay. Another one? A vote?
The difference between experimental probability
And the trial.
experimental probability
And?
and theoretical probability.
Okay, thank you. There is a term we are bringing in which is called experimental probability. So the key question for today is, what is the meaning of experimental probability? So, by the end of this lesson, everyone should be able to know. We are aware of theoretical probability as we've seen in previous lessons. Now, what if we are now into practice? What if we are doing experiment? What is the difference between this theoretical outcome and this experimental outcome? So let me welcome another teacher to continue with the lesson. Yeah, welcome Mr. Joseph.
Morning again. I'm by Mr. Joseph. Previously, from what we have seen or from what we have studied, the theoretical probability, we are going to continue by answering the question I'm writing here in the board.
Okay.
Okay. A creature with 20 items, example 12 red candies, 8 blue candies. If you grab one item without looking, what is the chance it is 11?
Okay.
Click on me and try to answer.
Yes.
Yes.
1/20.
1/20. Anyone who has another answer? Yes, you.
4/20.
Another? You.
1/12.
1/12. You.
8/12.
8/12. Yes. Thank you for your answer. Your correct answer is it?
It's for mine. Because 1/12, because you are going to choose a 1/20. You are going to choose 1 out of 20 items.
How?
How?
If you are going to choose 1 out of 20. So, yes, it's 1 out of 20.
You are talking about the rate. Why can't you choose 1 in 12? Better 12.
Teacher, help us.
Okay. Let me ask you, those who said the answer is different from him to defend his or her answer. Let me ask you, Thomas. Thomas, why did you say it is not one
For
for me?
me, referring to the question I write there, so a clear jar with 20 items. 12 are red and 8 are red blue. If you grab one item without looking, you will pick 1 out of 20.
Thank you. We have the we have the total items which are 20, and we have 12 legs. And we are going to pick one item randomly.
Yes.
And the chance of being a leg, it is 1 out of 1 out of
20.
12 out of 20.
12 out of 20.
the chess solution. We have total. We have the total. Items which are 20.
Okay.
And we are going to choose one leg from 12. If we take all items which are 12, the possibility of being red is 12 out of 20. As we have the 12 blades and the others are blue. We don't consider the others. The true answer is 12 out of 20. Thank you for today, and let me welcome another teacher.
Good morning, class.
Good morning.
I am here as teacher Orange, and we are going to continue. We are moved from theoretical experiment. We are going to experimental probability. Okay? We are going to talk about experimental probability.
Okay.
Okay, about this word experimental probability, who can help us to tell us about what about experimental probability? You, Fabrice, tell us.
It is the probability someone can get after practicing a certain practice.
Oh, thank you. Okay, you agree with Fabrice? What Fabrice has said, you agree with him?
Yes, I agree with you.
Okay, thank you. Okay, about experimental probability, it's about practicing and do experiments, okay? In order to understand the word probability, experiment. And let me allow you, Claire and Damascene, to come in front to do this activity about experimental probability, okay? The thing you are going to do, in order to understand what experimental probability, you are going to pick randomly between this blue color and red color, okay? To pick randomly.
Yeah.
And you're going to tell us what you have got. Okay, start. Damascene, start.
So I got
Oh, wait. Five times. We're going to pick 5 times randomly. We're going to pick five things, and after you are going to tell us what you have done. And then look it up.
this. I have got all of them are legs.
Both of them are red.
Yeah.
Okay, Claire, and continue. Okay, Damascene, we are going to pick randomly five balls, and you are going to tell us what you have got. If it is red or it is blue. Okay, tell us how many legs you have got.
I have got 4 legs.
Okay, 4 legs. Then we will come and because in this table we're going to fill this table, complete this table by using what they have got.
Yeah.
We are going to report here how many blue Damascene has got and red Damascene has got.
Okay, Damascene has got four legs and one blue.
Okay, thank you. Flowers to build. And Ted is going to pick and tell us what. Okay, Claire, tell us how many heads both have you got and
I have got 3 heads and 2 blue.
okay, thank you. Eda, come here and hold what? Heads and hold. Flowers to Claire.
Okay,
They have got
they remind me. 3 reds and 2 blue.
okay, thank you. Wase Janvier, come here and do photo about this. What is it? We're going to complete this table by using photo.
Yes. For the first time they got 4 and the second is 3. 4 plus 3 is equal to 7. 1 plus 2 is equal to 3. Okay. And then this is equal to 5.
Okay.
This is equal to 5 also.
Yes.
And then the total is equal to 10.
Wow.
Thank you.
Yes.
Jean-
1, 2, 3.
Okay, and Damascene. Okay, thank you to your student, and I'm going to ask you. Let me ask everybody, what is the probability of getting red color based on this table?
The probability of getting red
Of
color.
getting red.
Okay. The probability of getting red is 7 over 10.
Okay, why here? Okay, thank you. Flowers. And let me ask the moon. What is the probability of getting blue color?
Okay, thank you. The probability of getting blue is 3 over 10.
Come here in front and wait.
May I go out?
Hey, you can go out. There's no problem. Okay, thank you, Lamour. And thank you. Let me welcome another teacher in the next phase called Benjamin Point.
Students, so we are going to proceed on understanding how theoretical probability and experimental probability are different.
Yes.
So then let's start by using the results we got from those 2 activities we done.
Yes.
So first activity was related to theoretical probability. Who can remind me what we got probability of red?
Me, teacher. Me.
Mm-hmm.
Teacher, me.
Mm-hmm. Gender balance, please.
12 over 20.
12 over 20. Boy. Where is boy for making percentage? 12 over 20 percentage? 60%. Okay, then experimental probability for second activity. Do you remember? Yes. Probability for getting red. Who can tell me the probability we got?
It was 7 over 10.
7/10.
Yes.
God, to make a percentage. Great?
70%.
Oh my God. Janvier, what is the percentage? The one who was sleeping. Percentage of 7/10. Make it.
0.3.
Is it right?
No.
Stand up, stand up. We are going to this. Clap your hands, please. Then correct yourself. What is the percentage of 7/10? Right? The scan is here. 70%. It's perfect. Is it perfect?
Yes.
Yes. He's right. He did. Okay? So here, let's concentrate again, please. Let's concentrate. Joseph? So here we are going to see how theoretical probability and experimental probability are different. You see that by theoretical probability, we got 60%, where experimental probability was 70%. So then, which one we can choose as appropriate probability answer? Who can tell me? Which one?
The one from experimental probability.
Why? Send your answer.
Because in experimental probability, you got the probability by practicing. By practicing. Then that one for theoretical probability, you imagine not doing the practice.
Not doing practice. Perfect. What special positive reinforcement hours we can give her? Let me cook it.
Yeah.
Cook it.
Yeah.
Some more ingredients.
Yes.
Then pass it up.
Oh, thank you.
Okay, so it means that for experimental probability based on hitam on practice. Okay? On practice. So then how many practices we did for experimental probability activity? Who can tell me? How many? Because we saw that experimental probability based on practices rather than assumptions. It means for theoretical based on assumptions or predictions.
Yes.
But for experimental probability we based on practice. Then we did that activity. Second activity related to experimental probability. How many practices we did? Because as long as you make more practices to combine together to get the same conclusion or one conclusion, that's how the accuracy increase. So then, how many practices we did?
Okay, currently we have done two practices. One was done by Damascene as
We done two practices. One for Damascene,
Another for
another for prayer. It means as we be looking forward, as long as you increase the number of practices you do, that is how much this gives you the accurate way of concluding.
Yes.
Then, for making a conclusion, which is appropriate probability method, appropriate method of you can emphasize in your daily activities. You are going to tell me, okay. You are going to raise your hand. For one who will choose theoretical probability, put your hands up. For theoretical, two. Experimental. How many? One count? 7.
For me, I choose the theoretical because it does not require many materials.
Many materials. No need of materials for experiment, for theoretical. Okay?
Yes.
For experimental, who can defend from one who chooses it, okay?
Okay, me, I can choose experimental probability because even though it may require too much time and plenty of materials, but it is more accurate because we are not predicting, we are just recording the accurate data from the practices and the experiments.
Yes. Perfect. So I think you have understood how theoretical probability is different from experimental probability, and for each and one another advantage and disadvantage. And because this one gives accurate result, that is what we can choose. Thank you. Let's welcome another teacher for progressing.
Good morning once again.
Good morning.
Okay, we are going to continue this session with teacher Chantal. Yes?
Yes.
Previously we had this cup containing 12 items. Yes?
Yes.
We had it had 20 items.
Yes.
Among them we have 12 red and 18 blue. Then we are going to have another 10 green balls. Yes?
Yes.
We are going to add this 10 green item into this jar. Yes?
Yes.
Let's add them.
Yes.
Then what is the total? What is the total of our item in our jar? A golden.
The total item is 30.
Yes. Total item we have is the 30. 12 for yes, the sample sequence, the total item. We have 12 for green, for red, 8 for blue, and 10 for green. Then my question is this one. If we have 30 green balls, no 30 items, what is probability of getting red items among this one or this one? What is probability of getting red balls? What? We have 30 items here. What is the probability of getting red? What is probability of getting red?
I was thinking about it
Yes.
and sharing with my colleague.
Yes. Then
Okay, we are concluding that since you had 30, the probability of getting a red is 1 out of 30.
1 out of 30. Others, what do you think? Marie,
For me, I think that probability of getting red is 12 out of 30.
probability of getting red is 12 out of 30.
Yes.
Fabrice, do you agree with Greg? The probability of getting red is 12 over 30. Do you agree with her?
I agree with her 100%.
Yes, come and write the answer.
Okay. Since the sample space has increased, so you can write just the probability of red is equal to 12 out of 30.
Congratulations. Clap for him. Thank you. Then, my another question is this. Why do you think that the probability has changed? Before, we had the probability of getting red as 12 over 20. And now we have 12 over 30. Why do you think the probability has changed? Why?
changed because we have added the green candies into the jar.
Yeah, thank you very much. Our probability of getting red has changed because we have increased this item. Thank you very much. See you.
Hello class.
Hi.
I'm named by teacher Evode. Now it's the time of evaluation for what you have done in this lesson. So I have the question for evaluation. The question is, so the question is this, if you grabbed the one items 100 times and got 55 red, is a J mostly red. Use your notebook to do this question individually. Do it quickly. Okay. Who have finished it?
Maybe
Yes.
I was trying to think that.
Who have finished?
Teacher me.
Five.
Okay, so who can come in front to answer the question? No one?
Come.
Fabrice,
Yes.
come and write the solution.
Solution. The first one was, is the Jamos relay? First is yes. And this probability 55 over 100.
Why? Expect for that?
Explain for you. So we are just having 55 lead candies in 100 in 100. So it is 55 over 100.
Oh, understand.
So if more than 50% of candies are red, so the jar is mostly red. Yes. As simple as that.
Yes. Okay, thank you.
Thank you.
I want to welcome Akeza Eda.
I hope everyone have notebook of homework.
Yes.
So, write this homework. Out of 5